Have you ever struggled with software that fights back? You add one feature and suddenly two others break? You try to refactor and the whole system collapses under its own weight like a house of cards. Why? Why does this happen? And more importantly, how can we stop it from happening? How can we fix it? Hello world, I'm David Scott Bernstein and welcome to The Passionate Programmer. This video kicks off an exciting new series about mastering the hierarchy of software concepts. These are critical concepts that I don't see discussed very often, but they really lay the foundation for understanding how to write good code. Without knowing these concepts, you could have all the practices and all the techniques in the world, but applying them will be difficult and oftentimes incorrect. When you understand the core of what good software is, then you know how to create it easily in a very straightforward way. And so the techniques then that I'll share with you will become really easy because you know exactly how to use them to get the result that you want. But first, you need to know the result that you want. It's not just, oh, the software is good or it's clean, but there are, characteristics of good, clean software. And those are the things that we're striving for. Those are the things that make all the difference when we know how to look for them. Ways that allow us to evolve our software. And that's critically important because, as you probably know, most of the time when we start a project, we start from scratch. And we don't want to do that. We want to be able to start from a good solid base. We don't want to have to keep rewriting stuff. So when we understand really what good code is, the characteristics of them, and how to elicit them, everything changes. Developers say to me, now I know what to do. I was dealing with a mess. I saw we had all this legacy code, but I had no idea how to address it. Now I do. And so I think this is the missing piece. So, there's 20 or 30 episodes in this series. I've constructed it in a way that we could really dive deep. And I really believe that this is worth our time because these ideas, these skills, these distinctions will help you become a senior software developer, will help you tame some of the hard code that's out there. And with it, you'll be able to deal with anything. But there are no magic pills or silver bullets. If you want to truly master software development, then you have to put in the time, just like with anything, right? I believe that developing software is one of the most complex activities that humans can engage in. This crucial foundation that we'll explore, I rarely see other people talking about. And it forms the essence of what I understand of is good code. Understanding what good code is and how to create it is absolutely critical to success in software development. It's the difference between an entry-level junior developer and a seasoned senior developer. Understanding what the right trade-offs are. And we can only make the right trade-off decisions when we understand what good code is. What is good code to you? What do you think good code is? Because when I ask developers, and I've asked thousands of developers in my classes, what is good code? What is code? What are the characteristics of code you would like to work with? People get tongue-tied. They have a hard time articulating. Now, we can recognize what good code is when we see it, but how to create it, how to conjure it in our minds, it's harder. And so being able to have that top of mind, being able to understand the characteristics of good code really means that we can apply our development skills into an existing code base. And after this series, there will be no code bases that you cannot touch. You'll be able to reach into any code base, including the most intractable software, and fix it and clean it up. You'll have the skills to be able to understand how to assimilate the techniques around refactoring, around writing good unit tests, around making your software fully reliable. So sit back and dive in with me. We have a lot to cover. We'll dive into what good code looks like, the virtues and qualities, and specific principles and practices around creating it. By the end of this series, you'll not only understand key factors behind great software, but you'll also have the practical tools and skills to apply them on projects. Let's start with a simple question. What's the biggest challenge you face when building software? Is it managing complexity, reducing technical debt, or keeping up with changing requirements. The truth is that all of these problems stem from the same cause: building software without a guiding framework. Without structure, our code becomes fragile. Our teams lose direction, and we end up working harder than we really have to. This is why guiding principles are essential in virtually every discipline. If you study building architecture or medicine or the law or anything, you'll find that there are principles that have been distilled by people who have been studying this for generations. And these principles are a fast path to a deeper understanding. The law, medicine, these are disciplines that have been existing for a long time, thousands of years. And although they have grown slowly, they have had a lot of time to mature. We don't have that luxury. Software development is a young industry, and we haven't figured everything out yet. We haven't figured out and distilled out the principles that underlie what good software is. And I want to make a first attempt at that. And that's what this video series is about. It's about extracting out what is good software so that we understand how to evaluate practices and principles. I can tell you as a developer, many of the practices that I see in industry that are being used in industry to write software right now are not optimal. They end up creating more messes than clarity. And you don't have to take my word for it. Look at industry. Look at every single business out there. Very few of them have code that is straightforward to work with. Legacy code is such an issue that, books have been written about it, including my book. And what I found out when I was researching this book, my first book, Beyond Legacy Code, I realized that legacy code is the number one thing impeding industry, the number one thing. We don't think about writing code that lasts. What we think about is getting the job done because we have a deadline and we have this thing that we need to do, and we're just going to do it. The problem is that oftentimes the way we do it without taking care ends up causing more problems than it actually solved. And I see this time and time again. And once again, it's that we don't know how to apply the practices correctly. So stick with me because all of this is important. All of this is about changing the mindset in software development. And that's the key. You don't need another technique. I can give you all the techniques that the top developers are using, and they're not going to do you much good because you have to understand how to use them. And they're very subtle. There's very subtle applications. All that stems from being able to recognize what good software is. And that's why I have this hierarchy of software concepts. I've distilled over 40 years of experience in this one diagram that we'll cover. And we'll talk about many ways of seeing software to be virtuous, to be good. So without guiding principles, developers wind up, hacking in code any way that they can. And this creates code that's not very flexible, that's fragile, that's hard to work with. And this is what we see in industry today. And you might be working at a smaller company or a very large company. You might be working with an enormously successful company or one that's, just struggling to get by. All companies, almost every single company has legacy code. It is the price of success. If your company has customers, then it's very likely that you also have legacy code, because that's just the nature of it. When software is used, it needs to be changed. It's almost a universal truth. And in order to keep up with change, we have to write software that's changeable. The devil's in the details. The textbook examples are so simple that you don't see the flaws. But once you start building into a system over months or years, I know systems that are decades old, and it accumulates. And suddenly these bad practices snowball. And in the end, we wind up with a big problem, a big ball of mud that's hard to clean up. So the things that we'll talk about in this series will help prevent that from happening. Will help you see what good code really is, and then you'll know how to apply the practices to achieve them. This is the key thing more than anything else. I've built my career on teaching senior software developers new techniques and new approaches, and I'm trying to push the state of the art in software development. But of everything that I've seen and learned from other developers, to me, this is the most important because this lays the foundation for everything else. Understanding what good code is and seeing these, and I'm going to give you dozens of characteristics for what good code is, because we all have different perspectives. So, some people recognize redundancy, for example, really easily, but other people recognize, cohesion. Whatever it is, you'll have a variety of different characteristics that you can work from so that you can recognize the aspects of good code and where those pieces are in relationship to things that are not working so that you can ferret out those things that are not working and replace them. The hierarchy provides a big picture. It helps align on what matters really the most. Years ago, I worked on a project for a financial company. The team was brilliant, but the code base, not so much. Every small change triggered cascades of bugs. Features that shouldn't have taken days stretched into weeks. It felt like we were building on quicksand. Then we discovered a better way, a structured framework that helped align our code with key principles. Within months, productivity skyrocketed, and so did the team's morale. This framework became the foundation of what I now call the hierarchy of software concepts, and this is what I want to share with you in this series. This hierarchy is built on 5 layers. Each represents a fundamental aspect of great code. Together, they form a complete blueprint for creating systems that are adaptable, maintainable, and refinable. Let's explore each layer. Virtues in code are the core values that guide every decision that we make as developers. They're like the roots of a tree, unseen but essential for growth. They remind us of what our priorities are. And what's truly important is to keep things simple, clear, and adaptable. Early in my career, I worked on a project where deadlines were tight and temptation to cut corners were high. But one team member insisted that we stick to the virtues of simplicity. His discipline saved us countless hours down the road because we weren't untangling needlessly complex code. The next level up is qualities. Qualities are the characteristics that make software easy to read, test, and change. They're the guardrails that ensure our systems are a joy to work with and not a nightmare. Clean code isn't just code that's easier to maintain. It's faster to extend. It saves time and money. Principles are time-tested guidelines that help us make informed decisions in the face of complexity. They're the rules of the game, like chess. They don't guarantee success, but they drastically improve our chances. They give us a framework to work in. So why does this matter? Principles keep us focused. They prevent common pitfalls, like over-engineering or under-planning. We'll cover 7 key principles. Next up are practices, which is really about turning theory into action. Once we understand the underpinnings of good code, we can look at what practices support that. And so I have some very specific practices that I want to share with you. These are daily habits that can bring the principles to life. It's where the rubber meets the road. Consistent practices ensure that every line of code contributes to the bigger picture. I once worked on a team that embraced test-driven development. At first, it seemed like it was extra work, but over time, it transformed our workflow. Bugs decreased, confidence increased, and we started to deliver much faster. Test-driven development, if you haven't experienced it, is not what it seems. A lot of the practices that I talk about are not really what they seem to the outside. A lot of people who sort of read about it or hear other people talk about some of the extreme programming practices like test-first development, refactoring, pair programming, get a misunderstanding really of what they are and how they are to be effective. So understanding these practices is really important. And again, it comes back to understanding the hierarchy of software concepts. Once we understand these concepts and how they relate to each other, then everything becomes much clearer. And all of these things, the virtues, the qualities, the principles, and the practices, Lay the foundation for patterns. Patterns are reusable solutions to common problems. They're like recipes that save us time and ensure consistency. Design patterns are amazingly powerful, and I have a somewhat unique view of design patterns. Why is this hierarchy life changing? When you understand the hierarchy, you stop seeing code as isolated tasks. Instead, you see every decision as fitting into a larger picture, a larger system, a system that evolves gracefully over time. If this framework resonates with you, then hit the like and subscribe button. Let's build a community of developers who don't just write code, they create solutions that last. We want to build systems that are resilient to change and reduce technical debt as we're building software. This increases our productivity. Solving a problem and making a mess at the same time isn't necessarily very good. It can be a bigger problem than the original problem. Learn how to tackle complex projects with confidence using the skills that we'll be talking about. When you're able to identify virtues in code, qualities in code, and principles of good code, then you can apply the practices to their best advantage. After introducing this framework to a struggling team, I watched their mindset shift. They stopped reacting to problems and started anticipating them. They addressed them before they even became problems so that they never came up. Deadlines started to become met, quality improved, and for the first time in years, they felt proud of their work. In the next video, we'll unpack the core virtues of great software. These values are at the foundation of everything else in the hierarchy, and mastering them will change the way you approach every project. So don't miss it. If this video isn't up yet, then hit the subscribe button and the bell icon to get notified when I release it. Until then, happy coding.